Lesson 6.3 is on slope or rate of change. They're basically saying the same thing. Slope and rate of change are two words for the same thing. My learning target, I can find the slope or rate of change from a table or a graph. All right, here's an example. You should make sure that this is in your notes. Rise over run. So this is how we figure out what the slope or the rate of change is from one point to another on a graph. We're going to look at the rise on the top of the fraction and the run on the bottom. Or in other words, the change in your y, remember these are your y values going up and down, over the change in the x. So basically what I want to know is how much is something changing from one point to another. And so let's look at this graph, for example. I'm going to count how many boxes it goes up. It goes up 2 boxes. And since there are no labels over on this side, I'm just going to assume those are just 2 units. So I'm going to write 2 on the top. And on the bottom, I'm going to count the run. 1, 2, 3, 4. My slope, or my rate of change, is 2/4, which can be simplified to 1/2. Fractions, I feel like, are easier to write a slope in because it's telling me I'm going up 1 every time I go over 2. If I write this as 0.5, that's not wrong. It's the same thing. It's also saying 1/2. But it's harder for me to look at that and then graph it later. You don't need to do that now. However, I feel like in the future you're going to prefer them to be written as fractions. All right, here's another example. We're going to find the rise over the run. This time we need to take note of what is it counting by, because going up and down, it's counting by different numbers than it is from side to side. So I can't just count this as 1, 2, 3. I have to notice that this side is counting by tens. So I'm going to count this as 10, 20, 30 on the top. Okay? And then noticing on the bottom, this is counting by 2s. So I'm going to go 2, 4, 6 on the bottom. Now, since this can simplify to a whole number, I'm going to simplify that. 6 goes into 30 5 times, so my slope or my rate of change is 5. Here's another example. I'm looking for 2 points on my line. Now, it's not always going to have these little triangles like that, so you might need to find 2 points on your line. Where the points that I want you to pick are where you notice that the line crosses where 2 of these lines come together. Notice how this spot right there is not very easy to tell where it is. Don't choose that one. So just skip over until you find another good point. So I'm going to count, noticing here that each one of these boxes, it looks like each box is 10 because that's 10, 20, 30, 40. So each box is 10. I'm going to count by 10s, 10, 20, 30 in the top. And then this looks like it's counting by 0.5. So if I go 1 spot, that's 0.5, 2 spots, that's 1. 30 over 1, that can simplify to 30. This time it has labels to it, so I'm going to say, what does that mean? 30 was this direction, so it's 30 miles per, that line means per, 1 hour. Or I'll just write per hour. So it looks like a rate or a unit rate there. Rate of change and slope is kind of another way of saying unit rate based on a table or a graph. Okay, one more table. I'd like you to try this one and see if you can do it. All right, so you should have found any 2 points. I'm going to go with these 2 middle points. I'm going to go up. When I go up 1, it looks like it jumps by 5, so 5. And I might label that just because it has a label, $5. And then this way it goes over just 1. So it looks like it's $5 per movie. Here we have a table. Tables are slightly different. We're going to look at the change on the left side and the change on the right side. Sometimes we have to decide which ones are Y and which ones are X, but always remember the Y, if it's labeled, goes on top and the X goes on the bottom. So here I've got 4. Here I have 4 again, and here I have 4. What am I saying by 4? I'm saying 26 to 30, that's a jump of 4. 30 to 34 is a jump of 4. 34 to 38 is a jump of 4. So how much is this changing by? This is changing by $2. So it's going up by $2. Oops, each time. All right, so we have to decide, are we figuring out money per pound or pounds per money? And it says, what is the rate of change in dollars per pound? So I'm going to put the dollars on the top, $2, and the pounds on the bottom. And I want to know how much is it for one. So basically I'm going to find the unit rate for dollars per pound. So I'm going to divide this, 2 divided by 4, and I'm going to get 0.5. And in money, that would be 50 cents. So 50 cents per pound. Here's another table. It just goes the other direction. Remember, the Y change should go on the top, and the X change should go on the bottom. These should be the same as we go throughout because we're working with a constant rate of change, so it should be the same each time. So I've got 300, 300, 300, and so on. So the number of riders is changing by 300 every time, and the number of minutes is changing by 10 every time. So I'm going to put 10 on the bottom. Okay, so now I'm going to divide this until it's in simplest form, so I can say that's 30 per 1. What does that mean? It means 30 riders per minute. Because I took this label, riders, over that label, minutes. Try this one. Pause the video. Okay, so you should have noticed that this is changing by 1 on the years, and the height is changing by 2. So it says, use the table to find the slope or rate of change. It's not telling you which one's your X and which one's your Y. Sometimes you have to try and make the best sense of it as you can. So do you think it should be how many years per inch or how many inches per year? And for me, if I'm trying to figure out how much I'm growing, I'd want to know how many inches per year am I growing, not how many years does it take me to grow an inch. So I would do inches on the top and years on the bottom and label that there's 2 inches per year. That makes the most sense to me. Sometimes you just have to use your common sense and try and figure out which one makes more sense when it's not accurately labeled. All right, try one more. For this one, you notice that it's changing by 4s on this side. And on this side, it's changing by 3s. Again, we need to use common sense. What do we think? So here, do we think it's how many hours per degree or how many degrees per hour? For me, I feel like that's pretty easy to know that degrees goes over the hours. So 3 degrees for every 4 hours. I could call that 0.75 degrees per hour, or 3/4 of a degree per hour, either way. Whenever you see time, time always belongs on the bottom. It's just where it belongs. Whenever you see money, money belongs on the top. So those are 2 dead giveaways, and those are 2 things that you often see in a problem, is time and money. All right, it's time for your NICU check. Good luck.